A hyperbola is the set of all points in a plane, the difference of whose distance from two fixed points in the plane is a constant. The term difference that is used in the definition means the distance to the further point minus to the distance to the closer point. The two fixed points are called the foci of the hyperbola. The midpoint of the line segment joining the foci is called the center of the hyperbola. The line through the foci is called the transverse axis, and the line through the center and perpendicular to the transverse axis is called the conjugate axis. The points at which the hyperbola intersects the transverse axis are called the vertices of the hyperbola. We denote the distance between the two foci by 2c, the distance between two vertices, the length of the transverse axis, by 2a, and we define the quantity b as root of c square minus a square. Also, 2b is the length of the conjugate axis. Eccentricity. The ratio E equals to C by A is called the eccentricity of the hyperbola. Since C greater than equal to A, the eccentricity is never less than 1. In terms of the eccentricity, the foci are at the distance of AE from the center. Standard equation of hyperbola. The equation of hyperbola is the simplest if the center of the hyperbola is at the origin and the foci are on the x-axis or y-axis. The two such possible orientations are shown in. Let us derive the equation for the hyperbola, shown with the foci on the x-axis. Let f1 and f2 be the foci and O be the midpoint of the line segment f1, f2. Let O be the origin and the line through O through f2 be the positive x-axis and that through f1 as the negative x-axis. The line through O perpendicular to the x-axis be the y-axis. Let the coordinates of f1 be minus c, 0 and f2 be c, 0. Let p of xy be any point on the hyperbola such that the difference of the distances from p to the further point minus the closer point be 2a. So given p f1 minus p f2 equals to 2a. Let p of xy be any point on the hyperbola such that the difference of the distances from the p to the further point minus the closer point be 2a. So given p f1 minus p f2 equals to 2a. Using distance formula, we have root of x plus c square plus y square minus root of x minus c square plus y square equals to 2a. Rearranging and squaring both sides, we get x plus c square plus y square equals to 4a square plus x minus c square plus y square plus 4a root of x minus c square plus y square. Root of x minus c square plus y square equals to cx by a minus a. On squaring again we get x square by a square minus y square by b square equals to 1. This is the equation of hyperbola with origin 0, 0 and transverse axis along x-axis. Note: a hyperbola in which a equals to b is called an equilateral hyperbola. On the equation derived above, we have the following observations. First, hyperbola is symmetric with respect to both the axes. Since if x, phi is the point on the hyperbola, then minus x, y, x minus y and minus x minus y are also point on the hyperbola. Second, the foci are always on the transverse axis. It is the positive term whose denominator gives the transverse axis. Latus rectum. Latus rectum of hyperbola is the line segment perpendicular to the transverse axis through any of the foci, and whose endpoints lie on the hyperbola. As an ellipse, it is easy to show that the length of the latus rectum in hyperbola is 2b square by a square. Example: find the coordinates of the foci and the vertices, the eccentricity, the length of the latus rectum of the hyperbola. Solution: comparing the above equation with standard equation of hyperbola, that is x square by a square minus y square by b square equals to 1, we get a equals to 9 and b equals to 6. Thus we know that the vertex is given by vertex a 0 and minus a 0 equals to 9 0 and minus 9 0. Length of the latus rectum equals to 2b square by a square equals to 2 into 36 by 81 equals to 8 by 9. Eccentricity E. E square equals to 1 minus b square by a square, which is equal to 1 plus 36 by 81 or 13 by 9. E equals to root 13 by 3. Now foci will be AE 0 and minus AE 0, which becomes 3 root 13 0 minus 3 root 13 0. Example: find the equation of the hyperbola with foci 0 plus minus 3 and vertex at 0 plus minus root 11 by 2. Solution: since the foci is on y-axis, the equation of the hyperbola is of the form y square by a square minus x square by b square equals to 1. Since the vertices are 0 plus minus a, we get a equals to root 11 by 2. Also, since foci are 0 plus minus 3, c equals to 3. Now, c square equals to a square minus b square. Substituting c and a, thus b square equals to 25 by 4. Now the equation of ellipse becomes y square by 11 by 4 minus x square by 25 by 4 equals to 1. Example: if even is the eccentricity of ellipse having equation x square by a square plus y square by b square equals to 1 and E2 is the eccentricity of a hyperbola passing through the foci of the ellipse and even E2 equals to 1. Find the equation of the hyperbola. Solution: let us first find the eccentricity of ellipse. Even equals to root of 1 minus b square by a square, which is equal to root 1 minus 16 by 25, that is even equals to 3 by 5. Now foci of ellipse are 3, 0 and minus 3, 0. Also even E2 equals to 1. Then we have E2 equals to 5 by 3. Since E2 is the eccentricity of the hyperbola, we have E2 equals to root of 1 plus b square by a square. Hence putting E2, we have b by a equals to 4 by 3. Now let us assume the equation of hyperbola be x square by a square minus y square by b square equals to 1. Now it satisfies the foci of ellipse, which are 3, 0 and minus 3, 0. This gives a equals to 9 and also b equals to 12. Thus, equation of hyperbola is x square by 81 square minus y square by 144 square equals to 1.